In this video, I'm going to go through problem 1014 at the end of chapter 10 on the shape hierarchy. Okay. And I'm not going to do the whole thing as usual. I'm going to do just an overview. So here is kind of a rough view of that figure 9.3 from the previous chapter. So in this case, we have a shape class that's the superclass. Okay, so I can go ahead and label this. So up here we have this is the superclass. It has two subclasses. Okay, so two-dimensional shape and three-dimensional shape are both subclasses of superclass. Okay, and then we have the circle, square, and triangle as the three different shapes that we're doing over here on the two-dimensional, and then on three-dimensional we have the sphere, the cube, and the tetrahedron. Okay, and my N fell off my tetrahedron somehow. Okay, so when we're trying to implement these, when I first was working this problem, I thought about making this abstract because we really don't want anything to be a shape. Okay. The problem with that, when I tried to do a shape array, it wouldn't allow me to do that. Okay. So I had to abandon that idea. Okay. But I was able to make the two-dimensional shape and the three-dimensional shape both abstract. Okay, so we won't be able to implement one of those directly. Okay, and again, one of the advantages to doing it that way is I was able to create in this two-dimensional shape an abstract get area function. Okay, which creates an obligation for each of these, all of the subclasses out of two-dimensional shape, to implement this get area. Okay, and then the same thing over here. I was able to do an abstract get area and a get volume. Okay, both of those again are abstract, which gives that obligation. So you have to, if you inherit from three-dimensional shape, for example, then your Eclipse is going to tell you, and when you try to run, it's going to tell you that you have to implement the get area and the get volume. Okay. And then for my example, just to keep the video short, I'm going to implement, or I did implement the circle, which has a radius. I can do a get area pi r squared. And then I did the sphere, which has, I think it's 4 pi r squared for the area, just the radius also. And then it's 4/3 pi r cubed, I think is the volume. You can Google those, figure those out. Okay. So getting it set up is one thing. Okay. But getting it to actually do what you want with that array of spheres gets to be interesting. Okay. In particular, and I'll show you the code in a minute, but when we get to something where we have our shape array sub whatever, sub C in our for loop, which has a C in it. Okay. If you want, there are some things that we can do here. Okay. We can, for example, look to see if it's an instance of, which will say whether that's going to be the class that you have. Okay. The class variable can then, that's a different thing. Instance of will tell you if it's a member of a certain class or not. Okay. But we can also, on whatever this object is, do a get class, which returns the class that you're currently in. That returns a class object that you can then do a get superclass on. It's a small c. If you need to get the superclass of the class you're on. Okay. The instance of can sometimes negate that. Okay. If you want to get the name of the class, there's a dot get class dot get name. Okay, which will return that. And you'll see these as we get to the code. And there's one case where I was trying to call the get area of a particular object. and it showed up as an option, but when I did, it went ahead and put in the name of the superclass. Okay, it popped it in automatically. Okay, and we'll talk about that when we get to the code, but that's kind of where we're headed on this problem. Okay, and again, I just did an abbreviated version of it, but I wanted to give you the basic ideas here. Okay, so let me go ahead and share Eclipse. I'll go ahead and share the desktop just in case there's a pop-up there. Okay, so go over to Eclipse here. So, and this was kind of odd. Okay, and it turns out that there is no thing that's shared among all of the concrete classes. Okay, so we can't really put anything else in here. It's just there as a placeholder. I tried putting the get area here because it's common to all of them, but if it were abstract here, it couldn't be abstract in the subclass, in the two-dimensional shape and the three-dimensional shape. At least I couldn't get it to do that. It gave me an error. So I just went back and took it out. Okay. But we can look at the two-dimensional shape. Okay. And it doesn't really do much either. Okay. We don't want anything to be declared as a two-dimensional shape. Okay. So we're going to make it a public abstract class. Again, the shape couldn't be abstract. But this one is public abstract class, two-dimensional shape. Is going to extend our shape class. Okay. And we're then going to have a public abstract double get area. Okay. Again, you can't put the body, it'll give you an error, even a blank body, you just put it like that. It creates the obligation in the things that extend the two-dimensional shape have to implement that. Okay. Then the three-dimensional shape is going to look very similar, except it has the get area and the get volume. Okay. So then going ahead and doing the instances, the concrete classes, are not too bad. Okay, we just have to look at what we're trying to get here. That for the public class circle, it's going to extend the two-dimensional shape. Okay, again, as soon as I did that, if I try to call this something else, okay, it's going to complain right here. It complains that it must inherit, it must implement the inherited abstract method two-dimensional shape.getArea. Okay, so the get area is not optional; it has to be done. And it has to have the same, has to be a double, all that. Okay. So all I'm doing is this regular class stuff, right? I'm just creating a radius, which is going to be a double. It's private. Okay. I then have a constructor for this class. I'm not calling the super constructor because there isn't one. Okay. The super is a two-dimensional shape, which has no constructor because it's abstract. Okay. That's going to call. And then the shape class also has no constructor because there's nothing to do. There's nothing to set up. Okay. So we can create a shape, but there's only the implied constructor there. Okay. So I can just create it like it's a regular class. So I have my circle constructor, it takes a double radius. It sets this radius equal to radius. I then put in an accessor and a mutator. I'm not checking any values. You probably should. Okay. You probably should check to see whether or not they're trying to put a zero value, something like that. Okay. So that's my accessor and my mutator. And then down here for the get area, again, I'm doing a public double get area. I'm returning, I'm using the math.pi. That's the static constant from the math library. It's pi, capital letters because it's a constant. And that's going to be the most accurate it can be given this system. So that's the math.pi times radius times radius. That's going to give me the area of a circle. Okay. Now I'm going to jump in what I've done here and go over to the sphere. Okay, the sphere is going to be similar in many ways, but this time it's going to extend the three-dimensional shape. Okay, it also has a private double radius. Okay, there's a way you could organize this that you could have a sphere and sphere and circle to both have a common parent, or to do other things, or even make sphere to be a inherit from circle or any of that stuff. But that's just not how they're doing it here. But you do have options, but that's not what they wanted here. Okay, so this one's the same deal. In fact, I cut over the code because it's just the radius. So the constructor is the same, except you change the name. The accessors and the mutators are the same. Okay, but on this one, because the three-dimensional shape has these two abstract methods, I have to implement both of them. Okay, if not, it's going to give me an error. These are required functions. So the public double get area, which this time is going to be 4 pi r squared. Okay, just look that up on Google. And then for the get volume, it's 4/3 pi r cubed. Okay, so I went ahead and put that in as well. Okay, so when we're going to test this, the test gets a little funky. Now, you certainly could, if you wanted, create a circle test and a sphere test and a square test and a tetrahedron test, any of those things that you want to do. Okay, if you wanted to do that, but I didn't do that because I just put it into one. And in my test, you're going to see kind of the final version. But I did play around to make sure I could do what I needed to do. Okay, that my get radius worked and my set radius, all that. Okay, that wasn't really part of what the problem said, but just it's good form to check that out. But then I erase all that because it didn't matter. Okay, what matters here? We're going to go through this bit by bit. So this is my shape test, what I called it. I started by creating just some random shapes. Now, you should have done the 6 shapes, so you have more to pick from than I do, and I would probably do an array that included at least one of each. But in my case, I'm just doing 3 circles with different radiuses, and I'm doing 2 spheres with different radiuses. Okay. Then I went ahead and did my shape array, or my S array, an array of shapes, just right here, just directly inputting them. Okay, so I didn't have to worry about saying them one by one. So I'm just saying that the shape, I put in the square brackets so Java knows that it's an array. It's called S array, so it's an array of shapes. And I've got the C1, S1, C2, S2, and C3. Okay. And again, these are not all the same class. There are 3 circles and 2 spheres, but all of them are in an is a relationship with shape. Okay, so we're using the polymorphism here to be able to do this. Okay, we're able to treat a circle as a shape and to treat a sphere as a shape. Okay, so that's what we're doing here. Okay, and then I'm not normally a big fan of the shortcut 4 here, but I think in this case it's just easier than all the other mess you would have to do. So what I'm doing here basically, I'm saying is for shape, C is my local variable. It's going to be called C as it goes through the loop. It's going to iterate through S array. So the first time through, it's going to be C1, then it's S1, then it's C2, then it's S2, then it's C3. Okay. And then the first thing that it asks us to do here is we had to print out what type of shape this is, what the class is. Okay. And to do this, okay, and again, I had to go through some things here. Okay, when you start with this C.get class, for whatever object, it returns what kind of an object that it is. Okay, what it's an instance of. Okay, the problem is that return is not a string, it's an object, basically. Okay, so you can do other things with it, like get super class if we needed to. But in particular, I needed a string so I could print. And this is pretty common in Java. You see this a lot. So once you have this get class, you then do a get name on all that. Okay. So again, the way I type that in, as I was going along, I did my C dot. Okay. Here are my options. The get class is the option that I want. Okay. For that one, I want to do a dot. And there's a lot of things here you can get, but the get name is one of those. And we see that returns a string. Okay, so that's going to print out, and I don't want to give away the ending there. That's going to print out circle or sphere or whichever other ones that you would happen to have. Okay, and then I needed this test here to see which kind of shape we are. Okay, and here I'm using the instance of. You could have also created variables for the class and the subclass, or sorry, class and superclass, and test it that way. But I think this one's a little more straightforward. So I'm going to say if C, that's the current, so the first time through we're talking about C1, if it is an instance of 2-dimensional shape, okay, which means it's going to derive from that. Okay, it's going to be in that hierarchy. Okay, so in the case of C1, C1 is a circle. A circle is a 2-dimensional shape. So that'll be true. So I'm then going to print out the area. Okay, and this is where through this 2-dimensional shape in here, I had to put some, there's no get area for shape. So I have to call not the shape, but the 2-dimensional shape. And it did that automatically. Okay, so let's see what I did here. So, well, I can just do it down here. So again, I wanted to do a C dot, okay, get area, okay. And when I did that, that's all I selected. Boom, it put the rest of the stuff in there for me, okay. And again, it's doing that because shape does not have a get area, okay. So it had to do that, okay. So here's our other option down here. You could possibly just do an else. In our world right now, there are only two-dimensional shapes and three-dimensional shapes. So it's probably okay just to say an else. But why not go ahead and make sure that if somebody changes to four-dimensional shapes later, it's not going to cause you trouble. So this one, again, else if C is an instance of a three-dimensional shape, then I'm printing out the area, printing out the word area. I did that as a print, so it'll print, on the same line. And then I'm getting the area. Again, I did a C dot get area. It popped up the three-dimensional shape automatically, okay? The same thing with the C dot get volume, okay? So again, we're just specifying that we're not talking about the shape get area and the shape get volume. We're talking about the three-dimensional shape of those things, okay? So it did that for me automatically. I printed out a blank line and I was done, okay? So when you run it, this is what you get, which is correct. So the first one is a circle. Okay, and I didn't check my areas, but I probably should. That wasn't the biggest point, accuracy on this. The biggest point is putting it all together. Okay. But yeah, then we've got the sphere. Then we've got the circle. The sphere has the area and the volume. We've got the circle with the area, the sphere with the area and the volume. Okay, and then we've got the circle at the end. Okay. But volume looks a little funny. I'd have to check those numbers. Again, that's a math issue, okay, that you want to check to make sure you're getting correct bits of information, okay. But anyway, that should be how that works, okay. And I'm going to go through and add, let's do the square and the cube, for example, okay, just to make sure that we're on the same page here. So I'm going to do a new class. Call this one square. Okay. Put it in the right directory. I think some of you reported, and I had the same issue myself. If you end up having all this works, you don't have to include anything like you would in C++, because it assumes they're all in the same path, or in our case, in the same directory. Okay, so make sure things are in the same directory. Okay, so the first thing I have to do here, and I didn't do any comments, and you really should. I'm going to say this is going to extend two-dimensional shape. Okay, it extends with an S. Okay. Now notice that we have an error here, and the error says that it must implement the inherited abstract method two-dimensional shape get area. Okay, so we know we have to do that. Okay, but to get there, we'll start with our member data. Okay, and on a square, all we have is a side, length of the side. Okay, so again, we can do these as ints if you want. We can do double, makes more sense, I think. So we're going to do a double. We're going to call it side. Okay, that's all we need there. We can then do our accessor, which is going to be, whoa, I forgot something. Private. Okay, this is going to be a public get side, public double get side. Okay, which is going to return side. Okay, still got the error here because I still haven't implemented that one, but I'm going to go my own way. I think it's important that you have a routine that you follow, and don't let Eclipse boss you around. Okay. Mutator, again, I probably should have some error checking here. Oh, I forgot to do a constructor. Constructor is the first thing. I was going to say, it's usually the case that that the constructor looks like the mutator. Okay, I'll say this dot side is equal to side. Again, I'm not doing any error checking. I should be. So So now here I can say my public, this is a void function. It's going to be a set side, which is going to take a double side. And again, if you had taken the time to do your error checking, it's going to look just like your constructor. This side is equal to side. Okay. So now I've taken care of my constructor, my accessor, my mutator. There can be other functions that you need, but that's all we're going to worry about. Okay. And then finally, I'm going to do the required method. I may have said function before, but I meant method. Okay, that's we have to have a public double get area. Okay. That's not optional. We have to do that. Okay. In this case, we're going to return. If it's a square, the area of the square is going to be the side times the side. Okay. So that's all we have there. Okay, that's there. That's working. I can save it. Okay. I can then go back to my shape test, and then I can make one of these circles. I'll just leave it C3, although that's crazy. Let's make it a square. So it's going to say square. That's I'm going to do an SQ1. It's equal to a new square with a side of 8. Okay, make it a side of 5. Makes it easy to check, so the area should be 25. Okay, and then C3 no longer exists, but I can go ahead and put in my SQ1 there. Okay, everything else should work, except now I should have a square. That's the last one. So let's see. I run it, and I get a circle, a sphere, a circle again, a sphere again, and then finally down here, a square with an area of 25, which is correct. Okay, easy enough to add. And in some ways, it makes sense doing it the way I'm doing it, rather than trying to get them all and test them. I now know that my circle and sphere work, so I can just throw in the rest of these as I go. Okay, so let's go ahead and do a file, new class on the cube. Okay, and it again wants to be in the same folder as everybody else. And the cube is going to extend the three-dimensional shape. Okay, and again, it's going to tell me now I have two obligations. Okay, I have the get area and the get volume. Okay. So again, in fact, I can go back if I want and copy all of this stuff. Because it should be the same, it's just changing the names. So I'm going to call this now cube. All that's the same, all that's the same. Okay. Now we have our required methods. We know from the square, we have to have this get area. Okay. So this is the surface area. Oh, that's why it's not correct. Let's see. Oh no, the area. Okay, but now we're talking about a three-dimensional. So there's the surface area and there's the volume. Okay. So let me check myself to make sure I'm not a crazy person, because you never know. That I want to get to DuckDuckGo, which I think is a better way to do things. Okay. To the area of a cube. Surface area of a cube. Okay. Surface area of the cube. Let's see. Equal equal to 6a squared, or 6 sides squared. Okay, I was thinking that because there are 6 sides to a dice, that would make sense. Okay, so it's going, from then we can say basically 6 times side times side. Okay, so that should give us the correct area there. And then the volume, I think it's just side by side, but side times side times side. Okay, but let's double check. Yeah, it's just here. Oh, that gave me everything. The side cubed. Okay, so then I just have to return side times side times side. Or I could have done the power function there, but that works as well. Side cubed. Okay. So now that we have that going, we're in good shape. Save this. I can go over here to my shape test, and now I can make, let's say, my S2. I'm going to make this a cube. CB1 is equal to new cube 2.0. Okay. So now this tells me that S1 is no longer a thing, so I can go ahead and change that to my CB1 down here. Everything else should work. Okay, so let's run it, see what we get. We get the area, the circle with its area, the sphere with its area and volume. We get the circle with its area. We get the cube with its area and its volume, and we get the square with its area. Okay. So looks to be correct. Again, you want to check your numbers to be on the safe side. And then the last thing, we just do the tetrahedron here. I'm not going to do those again, but oh, that we didn't have it all together, which was nice. One that I thought we had it all together. It was cool. There's the, yeah, they're not showing it in easy ways. Here we go. There's a surface area, and there's the volume. Okay, so there's a volume, and there's a surface area. Okay, and again, we're assuming this is a regular tetrahedron of edge length A. Okay, and you can go from there and get that for the triangle and all that. If you did triangles in a different way or tetrahedron in a different way, that's okay. But that's the basic idea. Okay, so I think that hopefully will explain how that works. It's Tuesday. We've got a meeting tonight, but I'm not going to release this Tuesday because a couple people needed a few extra days on this homework assignment, so I'm not going to release it until after that. Okay. If you have any questions, as always, make sure that you let me know.